here, we've got a nice example, example 3. So let's have a look at the solution for example 3, and you'll see there's pretty much nothing to it. But when we deal with example 3, we're not concerned about bending, we're concerned about axial force. Okay? So remember, if you want it to be super accurate, you can include everything. So axial force, shear force, moment, torsion. So in the case of a truss, we've got an equation that's pretty much identical to what we've just seen. But this time we're concerned with the axial forces. So how do we solve that? Firstly, method of sections, method of joints. You've got your force system, and you can work out your axial forces. All right, so I'm not going to teach you how to work out your axial forces in the truss. All right. Now, we want to work out the deflection there, at the end there, so we follow exactly the same principle. We apply a virtual force downwards at the point where we want to interrogate the deflection. So that's our virtual force of 1, and these are the axial forces. So again, I'm not going to cover how to calculate these axial forces. So let's apply the equation. So let's have a look at the equation we're going to be applying. And the equation is the internal virtual work is the real axial force multiplied by the virtual axial force divided by EA, and is going to be summed because we've got different members. So the way to do this is like an accountant. You write out a table, and your table tells you each member. So we've got 6 members. Work out the length of each member. Okay, so we've got member 1 to 6. We've got the length of each member. We've got the axial stiffness of each member, which is just EA, which we'll call 1.6 because every member is going to be the same. Put into your table the real forces from here, so you get all the real forces that you've just calculated. Put into your table all of the virtual forces that you just calculated by having a virtual force of 1. Keep track of the sign convention, whether tension is positive or tension is negative, it doesn't really matter. It's all going to come out in the wash. So the 2 negatives multiplied together give a positive, every negative gives a positive. You can add the whole bit